All right, so we've got, let's draw a picture of this. Bullet, block, hanging on a string. All right, our next scenario, we've got this magical instance where the bullet has stuck in the block of wood, but the block hasn't actually risen any height, you know? In reality, this moment never exists, right? So the bullet is stuck in the block of wood. It's not going any farther into the block of wood, but the block of wood really hasn't gained any height yet. That's, a little bit of inaccuracy, right? All right, and then in the final scenario here, right, this block has swung up to some height, right? It's no longer moving. It's some maximum height, right? All right. So let's solve momentum. When this collides with this, momentum will be conserved. So 0.0045 times 916 plus 0. The pendulum's not moving, so it's got 0 momentum. That equals, this is higher math. What's that math? 1.120 plus 0.0045. Wow, do I need to, it's 1.1245. All right, 1.1245 v. Let's solve for that v. So 0.0045 times 916 divided by 1.1245. And I get that the velocity is 3.6656 meters per second, right? Which, hey, we're on track, right? Okay. And now when it goes from here to here, this is kinetic energy turns into potential energy. So I'm going to say my 1/2 mv squared equals mgh in this case, right? So, and then notice the masses cancel. Once the bullet sticks in the block's mass doesn't change. So 1/2 3.6656 squared is equal to 9.81 h. All right, so square that guy, divide by 2, divide by 9.81. Oh, wow, it goes really high. H equals 0.68485. Well, hopefully these strings are real long. Right, if they're shorter than that, I guess what does it do? It goes up and goes meters. Ta-ta. Is that right? Did we get it right? We got it right. That's what I got before. So 0.685, I guess you'd say. H is 0.685 meters. Yeah. All right.